Let's take any right angle triangle. And what people realized was, suppose this is some angle. Even if I make a bigger right angle triangle with that same angle here, the triangles that are formed are similar, right? Angle, angle, they have the same angles, right? So then they are similar, this bigger triangle and the smaller. So by similar triangles, the ratios don't change. So one angle is 90, you fix another angle, then the ratios of the sides become fixed. That means the ratios of the sides are pretty much being decided by this angle, right? 90 is fixed. You set one more angle, then any triangle you make with those two angles has the same ratios of the sides. So people gave them names. The ratios, they gave them names. So the angles are typically represented by Greek letters and the sides by English letters. So it's just a convention. There is nothing that says you cannot do it any other way, but you may see that's called theta, right? So that we call that angle theta. Then this side, this one, you know, this is the hypotenuse, right? The one next to it is the adjacent, and the one opposite, called opposite, right? So these are the OH and AU that are appearing here. The ratio of the opposite to the hypotenuse is called sine theta. In short, this is written as sine theta, just taking the first three letters, right? So that is SOH is this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. In short, cos theta. Okay, and tangent and you'll see later in calculus why this is called tangent is opposite over adjacent. Also, you can notice that if you divide sine theta by cosine theta, that is h will cancel out, right? And you will get O over A, which is what tan theta is. So tan theta is equal to sine theta over cosine theta. Okay, when we have an equality like this, which is true no matter what this variable value is, these are called identities. This is an example of a trig identity, trigonometric identity, right? Tan theta is always equal to sine theta over cosine theta. What that means is, if you're trying to do something, you can replace tan theta as sine theta over cosine theta. Or if you see sine theta over cosine theta, you can replace that with tan theta because these things are always equal. Tan theta is always equal to sine theta over cosine theta. And their opposite ratios are also there. So instead of A over H, you can have H over O, right? If you did H over O, that's 1 over this. So this is 1 over sine theta, right? And there's a name for this, which is cosecant theta, also written as cosec theta. So this is just a short name for that, like these are. But it is cosecant, okay? And if I did opposite of this, H over A, I have 1 over cosine theta. This is called secant theta or sec theta in short. And if I do A over O, this is 1 over tan theta is cotangent theta or cot theta for short. Okay, don't be scared or worried about this. You know, as we do this, you'll become more familiar with this and it will all make sense. And the cool thing, a nice thing about these ratios is if you know one of these, any one of these, you can figure out all the 5 others. You just need to know one of them to figure out all the other ones. How would we do that? Because you know there are 3 sides, right? O, A, and H. If you know one ratio, you can figure out the ratio of 2 of these. And then the third one you can find by the Pythagorean theorem, right? A squared plus O squared is H squared. And once you know all the 3 sides, you know all these ratios, correct? Right, so let's take an example. Let's say I have, suppose I say sine theta is 1 over 2. Right? So that means sine is opposite over hypotenuse, right? So I know this is theta. This over that is 1:2. I don't know exactly what it is, but I know their ratio is 1:2. So if I'm only worried about the ratios, I can take them as 1 and 2. If I really want to be worried about the actual values, I could call this as, say, C, right? Since this is to this opposite to hypotenuse 1:2, so C, then this is how much? 2C, right? And what is this length? This I suppose this I don't know, right? So let me call this as X. So by Pythagorean theorem, I know X squared plus C squared is 2C squared, right? Which is 4C squared. Make sure, because this is 2C times 2C, right? There's a whole square, there's 4C squared. So X squared is 4C squared minus C squared, which is 3C squared. So X is the square root of that. So normally it would be plus or minus, right? But we are just looking at the lengths here, because it could also be negative root 3C, right? But we are just worried about the lengths here. So this is just root 3C. So this is root 3C. Now I know all the ratios, right? Because I know the 3 sides. So sine theta we already know. What is cosine theta? Is A over H. Root 3C over 2C. So C cancels out. Root 3 over 2. What is tan theta? So C over root 3C. So that cancels out. 1 over root 3. And then cosecant theta is 1 over sine. So when it starts with C, it is 1 over S. That's one way to remember. Cosecant theta is 1 over sine theta. So this is 1 over half, which is 2. And secant theta starts with S, so 1 over C, 1 over cosine is 2 over root 3. And cotangent theta is 1 over tan, so that is root 3. If I knew one ratio, one of these 6 trig ratios, I can figure out all the other 5.